Okay, so I wanted to make a video just on density. What is density? Well, in chemistry, first off, density is a physical property. And the reason it's a physical property is because density doesn't change the chemical makeup or the chemical formula of whatever we're dealing with. And let's use water as an example. Okay? Um, let's say these are the molecules that make up what we know as water. And what does water consist of? Water consists of two hydrogen atoms and an oxygen atom, and we've talked about that before. So this is what makes up water. Now, let's say this is the liquid form. Okay, this is the liquid form of water. And a good way to describe this is pretend that this is a soda can, and we put that soda can in the freezer, and you might think, well, a soda can doesn't consist of just water. There's other things in it, which is right. But water is one of the main things in that soda, and water is what causes. And let's draw this here. We'll kind of have it expanding like this. This is our soda can, and maybe not a very accurate drawing, but you get the idea. What happens when the molecules in water freeze? Okay, so this is when it's going from a liquid to a solid. When the molecules freeze, what tends to happen is they space themselves out more. Okay, they space themselves out. They give themselves more room, and what that does is it increases the volume. Okay, it changes the shape, and and that's why that ends up happening when you put a pop can in the freezer for too long. Okay, now so what happens here, and remember this video is on density, that's what I'm trying to talk about here. If we look at the density, we look at the density of water as a liquid, and then we look at the density of water as a solid. What happened? The density decreased, didn't it? Okay. Um, if you look at the visual that we just did here, it's obvious that the density decreased because the molecules spread themselves apart. Okay, so water is less dense in its solid form, and water in its solid form is known as ice. Okay, ice actually has a density of, if I remember right, something around 0.917. Okay, we know that water in its liquid form has a density of what? Of 1.000. Is there another zero? I don't remember. I think it's 1.000. And sometimes you wonder, well, why are these zeros here? And that's probably for a different video, but I'll talk about it a little bit. Because we know to this value that that's how specific it is. We know to this value, ones, tens, hundreds, thousands, that it's still 0.000 over here. So that's a different video. I don't have to talk about that right now. But the point that I'm getting at here is ice is 0.917, and we kind of made a picture of that, so that makes sense. It's less dense than water in its liquid form. And if you think about it, think about an iceberg. If this is the water, say this is the ocean, and then you have an iceberg that sits on top of it like this, it will, and I'll kind of color it in here. My drawings never cease to amaze me. They're always interesting. This one kind of looks like a dinosaur. Okay, so this is the iceberg sitting on top of the water, and it floats, doesn't it? Why does it float? It floats because our ice is less dense than the water. If it were more dense, it would sink. Another example that I can give you is body tissue, fat versus muscle, and I don't know exactly what the densities are here, but muscle is more dense than fat is. So a very muscular person would probably sink to the bottom of a pool because the density is more than water. With a person who might be obese, if they were to lay in a pool, they might be able to float because that fat is less dense than water, so it would float on top of the water a lot of the way a lot in the same way that an iceberg would. It floats on top of the water. The one thing that I'm forgetting to mention here is the formula for density. Maybe I should have done this first, but density equals mass divided by volume. An easy way to remember that is DMV, the place that we all don't like having to go, because the people aren't always very cheerful there. But anyway, DMV, I just remember it that way. So density equals mass divided by volume. Mass is always in grams, and then volume is either, let me think here, milliliters or centimeters cubed. Okay, and if you're in nursing, you know that a cc is the same as a milliliter, but we chart in milliliters, or you should be charting in milliliters to avoid any confusion, because the idea there is if we charted cc and we were sloppy with it, it could look like ounce. I'm not sure that really ever happens, but that's the reason we chart in milliliters instead of cc's. But again, I'm going off on a tangent here. Okay, what am I talking about? cc's, milliliters. Oh, okay. So a milliliter is an amount of volume. Okay, where a centimeter, of course, is really a length. But if we take 1 centimeter, and we take a square of that, and then we take a cube of that, and we measure it all out, and that's not the best picture, but you get the idea. And we measure that all out. It's the equivalent to a milliliter. Okay, so a centimeter cubed is the same as a milliliter. cc stands for cubic centimeter. Okay, so let's see if we could do an example here. Density. So okay, we'll just make something up. Let's use a new color here. And let's say we have, oh, I don't have my calculator here, but we'll use the computer. We'll resource here. Okay, so let's say, or maybe we'll use simple numbers. We have 20 grams. Okay, so our density equals 20 grams. And let's say we have 5 milliliters of that. What is the density of this? It is going to be 4. Of course, I picked those numbers because I can do that in my head. 20 divided by 5 equals 4 grams per milliliter. Okay, so hopefully this video gave you a little better understanding of what density is. Just trying to think what I'm going to do in the next video, but who knows? We'll see what I can come up with.